Good morning. Welcome to our business-focused webinar, Cloud as Business Enabler. Thank you for joining us. We have a great session for you this morning. Let me quickly cover a few items before we begin. First, everyone is muted. Please submit your questions into the Q&A box on the bottom right-hand side of your screen. Our speakers will answer them at the end. Second, we are recording today's webinar. All attendees will receive a link to the recording and a follow-up email. Today's speakers are Kevin Leahy. He is Aspire's Data Center Practice Director. And Sean McKeown, Cisco. He is Cisco's IWO lead for Global Infrastructure and Cloud. And Sean is the co-author of Intersight, a handbook for intelligent cloud operations. And now I will turn things over to Mr. Kevin Leahy. Kevin.
All right, thank you, Chris. And thanks everyone for joining, and thank you, Sean, for participating as well. And I have not written a book, so I'm anxious to learn from you as we go through this conversation. The title of the of the presentation, Cloud as a Business Enabler, seems a little bit maybe too obvious, you might say, because business drove the early adoption of cloud. So what are we talking about here? And I think the key point here is the business imperatives absolutely did drive the cloud adoption, and developers and business units, went out and did a lot. In many cases, it was out of the line of sight of IT. And they did it for very clear and important reasons, right? It was for speed, getting new applications, new services out to market, and user experience. They needed that excellent user experience. On top of that, then we had the pandemic, and certainly the pandemic accelerated that. And every client I talk to today has put more in the cloud than they ever intended a year ago. Not that maybe more than they ever intended ever, but certainly it's got there faster than they were intending. The rate and pace of change, accelerated more than anyone had planned for. Now, the problem for many infrastructure owners is the easy choice that enabled speed comes with cost. And I know personally, I was working with a client, happened to be a stock exchange, and every developer chose the largest image. They chose it because they wanted to get that application, they wanted to get it tested, and they wanted to roll it out and see the minimum viable product perform for clients. But as they mature, that scale grows. And isolated projects matured to integrated services. It wasn't a single thing, but now it had to access databases, it had to leverage more services. So it wasn't a single thing, it becomes part of a complex delivery model. And usually the operational implications were not considered. They did the dev, but not the ops part of DevOps. And that disconnect creates a challenge. And at the end, neither IP processes, or IT processes, nor skills were in place to support it. They weren't ready. And at the end of that, what does that mean, right? So how are you going to address that? End user experience defines your brand today. In the digital world, that is what defines how satisfied your clients are, how long they stay, and will they continue to use their services. But at the end of the day, the business, enabling that business means you have to watch your costs and you have to maximize your returns. And that means it's continually optimized, not like the old days where you did a CapEx purchase every 3 to 5 years. You looked at the total cost of ownership, you did some math and say, yes, this is going to work. In today's world, that's changing every minute. And so continual optimization is required, not revisited every 5 years as part of a capacity planning process. And so what does that mean? At the end, that means that you have to be application aware in infrastructure management. And you can't do it with static processes. You need a knowledge engine, and you need a platform that's going to allow you to continue to innovate, as well at the same time allow you to develop new capabilities at the pace that business requires. So with that, let me turn the table over to Sean to really talk about the Cisco Intersight.
Thanks so much, Kevin. Really appreciate it. And thanks for the opportunity here to speak with everybody today. The context here for Cisco Intersight Workload Optimizer and really Cisco Intersight as a platform. Cisco Intersight is a SaaS platform that we've been offering now for excuse me, a number of years. But we are in the last year or so really starting to expand its capabilities and its breadth beyond the sort of initial use case of infrastructure operations and hardware management, and really growing it into a cloud operations platform. And Intersight Workload Optimizer is a service within the broader Intersight platform that we debuted, I believe it was the end of November of last year or early December. And we're aiming with Workload Optimizer to really go after one of the core problems, maybe the core problem in IT operations overall. If we think about what we do in data centers in the process of delivering IT services, the prime directive, right? The fundamental goal ultimately is to deliver, excuse me, performant applications at the lowest possible cost. If we can do that, if we can get end users to have a good experience and deliver that experience at the least possible cost in IT operations, we're doing a good job. The problem is that it's not easy and arguably maybe not possible at the scale we're being asked to deliver today, with the number of workloads under management in a typical data center. I mean, we're talking thousands of workloads in many cases. And with the complexity of those workloads, those applications, we see these modern microservices oriented, cloud native, distributed architectures with loose dependencies between various services, some running on-prem, some running in the public cloud. And that level of complexity and the level of scale makes it arguably impossible for human beings to know what the right decision is at any given time to ensure performance and to minimize costs. And that's why we are offering with Workload Optimizer within the Intersight platform a SaaS delivered decision engine. It is a piece of AI, if you will, that analyzes the environment in real time and uses the information it learns from both public and private clouds to make decisions. And the concept, and Kevin, if you could advance the next slide, the concept is to solve a multi-bodied problem, really. And that problem is one where we have these kind of three legs of the triangle, these three vertices that are tugging against the other two constantly. We have to assure performance. If we don't do that, it doesn't matter how cheaply we deliver the service. It doesn't matter if the auditors are happy. If the performance is awful, the end users will complain, the business will suffer, and there's no point to it. But it's not just about performance. You have to do that, but you have to do that at the lowest possible cost, and you have to do that within your business compliance scheme. You have to ensure that you're following your HA and DR rules. You have to ensure that you're not violating your license rules and so forth. And so this multi-bodied problem is extremely difficult to solve once, and again, nearly impossible to do all the time in real time, to do it simultaneously for everything you've got in the data center. And so we're really driving, what we want to do is be driving toward a desired state in which this problem is essentially constantly solved as both supply changes and demand changes, as new infrastructure comes online or goes offline, and as the end user experience or demand rather is adjusting accordingly. You have new applications that come online, you have new users that come online or go offline. It's constantly dynamic and needs to be solved in real time. And because of that, and do I have the ability to advance, or can I rely on you? Sorry, Kevin, you can go ahead one more. That would be great. The way we learn about the environment, the way the software actually gets the information it needs, is by making essentially by making API calls to anything it can get its hands on, really. There are what we call targets in the data center, and these are things like your hypervisor environment, your storage array. If you have Kubernetes clusters, we'll reach out and talk to them. We can make API calls to Amazon and Azure, and we can critically make, we have direct integrations with APMs like AppD, Application Dynamics, which is App Dynamics rather, which is another Cisco offering that focuses at the application level for performance. And so with these rich sources of telemetry, we can ingest all manner of different metrics. So this is not some kind of very crude analysis of, say, CPU utilization and memory utilization. No, we're looking basically across every potential metric that has the effect that or could have an effect on performance or cost. We ingest the data and analyze in real time. So can you go to the next slide, please, Kevin? Thanks. What we do with this information once ingested is to effectively model it as a marketplace. So we discover the information, and then we essentially, kind of in an algorithmic way, model each entity we've learned about as a buyer or a seller of various commodities. So imagine a virtual machine that is buying memory, CPU, storage, and that sort of thing from a physical host and storage array, and consuming network resources from the network. So they're buying, the VM is buying those resources, and then it's turning around and selling those same resources to a container or directly to an application. And so we, having discovered all the information, we stitch together a supply chain, as you see on the left, which is essentially a relationship map of each of the components we've discovered and their dependencies on the other components within the infrastructure. And create these virtual auctions, if you will, behind the scenes in the algorithm, and use the results of those auctions, those buying and selling transactions, to generate actions. And that's the ultimate focus of the service, is to provide decisions and automate those decisions wherever possible. The automation is always an opt-in model. So we're never going to take action unless you allow us to. And so we're not talking about like unleashing Skynet inside your your data center. Don't worry there. But we can give you high granularity control over any actions that we do take. And so let's take a look on the next slide how we're going to actually do this. So we reach out and discover. Again, this is agentless. This is API driven, and the concept is to and actually, Kevin, if you can kind of click through this would be at least that. There you go. Yeah. So that supply chain is automatically stitched together, having retrieved the information from the targets that we spoke of earlier, and that information is updated constantly, right? So we're getting deltas constantly. So this is always current, the supply chain, and we can filter it based on either on-prem or public cloud, or both. And go ahead and click again, Kevin. Sorry, you might as well go ahead and build that all out. Yeah, there we go. So at the top there, that top arrow, we're pointing at the business application, and we've learned about that business application from AppD. So we can reach out, natively talk to AppD, learn everything it knows about the logical application, and use that to stitch together this relationship map all the way down through the physical. So we're connecting the logical and the physical here using that application App Dynamics integration. And once done, we generate those actions you see in the second arrow. And those actions, again, are constantly updated, constantly in real time. And we can even see down into, for the third and fourth arrows there, we can even see down into the business application level and business transaction level. So we can see how the underlying infrastructure is affecting business transactions. We can see the latency in those business transactions, the average response time, and know what to do about it. So, where you see red, you've got a potential problem from the infrastructure that we need to account for. And in any application environment, you're going to have really two pieces of the puzzle that need to work together. You have to have good code, well-architected application. And that's what AppD does extremely well. AppD is a phenomenal APM tool, application performance management tool, to show you what line of code is troublesome, is creating some latency, what database query needs to be refined. That is a critical piece of the puzzle, but it's not sufficient on its own. We also have to ensure that the applications get the resources they need when they need them from the infrastructure. And that's where Workload Optimizer comes into play. So the two of those together, working in concert and understanding the same logical application and its relationship to the physical, everybody's working off the same sheet of music, and we know what to do to fix the problem. So
I think you made a key point there, Sean. I just want to interrupt on it because I think it's important. AppD does a great job as the application changes, and you could see the implication of that, but you don't change your applications that often in many cases. But the load, the situation in the cloud, the traffic over the network, the number of users, the number of requests, et cetera, changes dynamically. And that I think is the key ingredient here, is to understand, where's the majority of the change happening? It's in the usage of the workload more so than the actual change of the application. And that's where, IWO is focused here, is really helping you respond to the minute by minute, second by second changes, as opposed to when you're going to, introduce a new service overall.
Great point.
And I think that's where most IT operations people struggle.
Absolutely. And again, it's what do you do about it? You can see there's plenty of tools that will say, okay, you've got a problem here, right? You've got latency is increasing on your shopping cart transaction. Okay, but what do you do about it, right? Where does the problem reside? And even if you can narrow down the where, what's the move to make? What action do you take? Do you vMotion a particular VM that's holding a container for a part of the application to another physical host that might have more resources? Do you resize that VM and increase the resources allocated to the containers that it's holding or serving? Do you need more storage bandwidth? What is the move to make to improve the environment? And if you advance the next slide.
Yeah. I just want to add one other point, because I think this is one that's pretty interesting, is our experience, and we've been working with this for a while, is clients generally don't necessarily trust. So to our business leaders on the call, your IT teams are going to look at a dashboard like this to start, because they want to see, why are you recommending this change? Once they start to see the why a few times, they realize that the tool has access to more information and that knowledge engine to make better recommendation. So what I've found is people start looking at the recommendations and inspecting the why, but very quickly move to accepting the recommendations almost immediately, because they understand behind the scenes what's actually included in it. So you'll find the adoption of the accepting the recommendation moves pretty quickly.
Absolutely. And so if we were to kind of click down into this particular business application that I've got highlighted there, you see the supply chain on the left adjusts automatically. The supply chain now is focused on just the one business application that we wanted to scope in on. And we're seeing just that application specific transactions and its response time, and the actions specific to it. So if you click ahead there, Kevin, I'm sorry to keep nagging you, but yeah, we're going to focus on the actions specific to this business application. And you'll see in there, we've got some very specific recommendations, as Kevin was just saying. There's two more arrows if you just finish out the build there. There's some very specific recommendations in your actions suggested here to, in some cases, help with performance. So we've got an example here where we need some more resources for particular VM in the environment. But we also have an opportunity to reclaim some resources because we're over provisioned. And knowing the difference between those two, and knowing which of these actions you can take, which actions to take to achieve that constant goal of moving toward the desired state. That's what the software knows, and it knows it at a level of detail greater than any human can do, can manage, and much sooner than a human could guess. And if you imagine, this is just one application. This is just one piece of the puzzle. The problem is across the entire estate, and that's where software just wins every time. It can handle the scale in a way that humans can't. Next slide.
The key, I think, is just to make the point on the efficiency. The efficiency is with the knowledge of the current consumption of that workload, so you can make those efficiency changes safely because you know how much resources required for that workload at that time, and that's very difficult for someone to do without that level of insight. And in the old world where these were VMs on a server, the efficiency benefits were not as immediate as it is in the consumptive world where these are cloud resources, where you actually save money by making that change.
Great point, and a great segue to the next slide, which is everything we just spoke of for on-premises infrastructure applies also in the public cloud. Here you can see we have kind of clicked on the public cloud tab there at the top, and again the supply chain resets and adjusts accordingly, and now we're seeing just the resources we're consuming in the public cloud. The problem in the public cloud is essentially the same, but it's kind of the other side of the coin from on-prem. So if you think about on-premises, we've got a fixed amount of resources, and essentially we want to consume those resources as efficiently as possible to defer to get the best out of what you own, and to defer future purchases as long as possible. In the public cloud, resources are essentially infinite. What's not infinite is your pocketbook, right? So the goal in the public cloud is to assure performance and spend as little as possible in the process. And to do that with all of the available templates, and whether it's Amazon or Azure, there's hundreds of different choices to make from a workload perspective. Which is it? M5 X large? Is it T3 nano? Is it B5 extra spicy? It's impossible to keep track, and their costs change all the time. And you have the option of buying them in an on-demand fashion, so a pay-as-you-go hourly rate, or lease the instances for a year or two or three. The permutations and combinations are essentially endless. And we've seen customers try again to keep on top of it with spreadsheets and complex, human intervention. And invariably you get it wrong, because things, even if you got it right once, even if you got it right at a point in time, an hour later, something has changed and it's wrong again. Right. And so if you Kevin, if you build out just the three big rectangles, I just want to highlight the specifics on the screen. Sorry, one more. Again, focuses on actions. What are the actions you can take right now to either assure performance and or save money? On the left there, you see the bottom left rectangle. We're talking about the investments you need to make in this environment to assure performance, and it's a modest amount of investments, but we've got some resources, some workloads that are struggling. They need some more resources. But on the right, you see the potential savings as well. Here are areas where effectively we are either over provisioned or misprovisioned on a any given workload, and there's an opportunity to save money as a result just by making simple decisions, simple changes. A big chunk of that savings comes from discovering and deleting orphaned volumes. These are storage volumes that somebody built at one point. They're not attached to any workload. They're just sitting out there burning money. Let's get those back, right? And lastly, if you click ahead, there's a plan tab there over on the left. And if we advance to that, because of the abstraction that we have here, this economic abstraction that everything is modeled as, again, a buyer or a seller, and then we can adjust for supply and demand in real time. We can also ask what if questions of the model. We can, in the algorithm, say, well, what if I were, we know what the real world looks like, but what if I were to make a change to either supply or demand? What if I were to say, add a physical host or 2 or 3 to my on-premises infrastructure? Or what if I were to take some away, or add new workloads or remove workloads? Or in this case, what if I were to take some workloads from my on-premises infrastructure and migrate them to Amazon or Azure? What would I need to purchase? What would that look like, and what would my costs be? And we actually provide 2 answers to that question. And on the left there, the blue column, that is a lift and shift answer, meaning don't make any changes to resources allocated. Just tell me what it is if I move things exactly as they are with the same amount of memory and CPU and storage and so forth. And then the green column offers the sort of right-sized answer. The answer, if you let the software do what it's good at and tell you where you can find some efficiencies, right-size things in the process of moving to the public cloud. And you can see one more click, you can see the difference in cost there. If you allow us to do 2 more clicks. You can, the bottom line there is significant savings if you allow the software to do what it's good at.
And so, I think one point I want to make on that, right? There are a lot of migration tools out there that can tell you if you move from here to here, here's going to be the savings or the expense. And even with the optimized column, that still represents a moment in time. The point that is so unique here is the continual optimization as your workloads and your variability changes, and that we don't have any other partner tool that we can work with that can deliver that continual optimization.
That's a fantastic point, right? This is a what if engine. It allows you to model questions like that, in a point in time. But once you get there, once you complete your migration, you're going to want the ongoing benefit of continually optimizing, because again, demand changes, supply changes, things constantly change. And so when when you look at an application environment and you can assure that the resources in the environment are being delivered in real time, the applications are getting the resources they need when they need them, then we've got good performance on the application side. We're being as efficient a steward of those resources as possible. We're making sure if we own capital resources, they're being utilized as optimally as possible. And if we're consuming public cloud resources, we're spending as little as possible in the process. We're making sure our policies are followed with respect to, as I said, licensing and placement and HA and DR rules and that sort of thing. And all of that takes a huge burden off of the day-to-day workings of your operations teams, who instead of having to kind of constantly be trying to guess at what the right decision is to make, or joining a war room to figure out, where we see a red light, what do we do about it? Is it the network? Is it the storage? Is it the application? Now everybody's working off the same sheet of music. Now we know where to go and what decisions to make. And so by taking that burden, significantly lessening that burden from the operations teams, they're free to do the value-added work that they would, I'm sure, in most cases, rather be working on. And so with that, I'll pass that back to to
Well,
Kevin
thanks,
to wrap us
Sean,
up.
and fabulous as always. I'll tell you, every client we work with, I've seen 1,000 examples where clients can prove it's cheaper in the cloud or it's more expensive in the cloud, depending on what answer they want to prove. But it's always based on a static comparison. And reality is you're not going to cloud for a static reason. The dynamics of the market, as we talked about earlier, force you to think about the challenge as cloud is going to scale, as consumption is going to change, as your enterprise goes through its digital transformation. So you need to do that optimization at the speed of cloud and at the pace that change is going to occur for your business. And those application outcomes define your brand. And so therefore they have to drive your decisions, and hopefully you've seen the value of that. So please reach out if you'd like to complete or continue the discussion. If you'd like a demo, we can show you how all these pieces come together. We've got a lot of experience working with this across our client base as well as in our managed services, and we're happy to help you really get your arms around the cloud that is going to drive the IT growth in your environment for the foreseeable future. Thank you for participating. Sean, thanks for the great insight, and hopefully every one of our clients on the call saw the benefit.
Thanks so much. Really appreciate it.